Everyone hear me well? Yes? Are we good? Okay, NG911 testing. This semester I chose to work on the NG911 project as part of my ITM 546 course. The main project was to basically become familiar with how NG911 works, how the call flow works in an NG911 system. And throughout the semester, about halfway through, we were contacted by the counties of Southern Illinois to do some performance testing on a real live NG911 system. So the project overview that I'm going to be talking about is the second portion of the semester when we were actually doing some performance testing on an actual NG911 network. And the NG911 network is production ready. Everything is set up and they are ready to cut over and start using this NG911 network in production mode. The project goals were to go ahead and stress test the different components. So they have a lot of components. The call flow for an NG911 system is very complex, and all of these different components have certain requirements to work. So we were asked to go ahead and stress test the different components and see if they are up to the standard and working the way that they should. So really quick, here's a network layout, and basically what we did is we were a test machine attached to both the public side of the SBC or firewall and to the private side, the actual EZNet. So as you can see in this diagram right here, we were testing only two proxies found within the network. Once the call flows from the public internet to the SBC and through the proxies, it passes on further down the network. However, during our testing, we only tested these elements. And a quick information about the different elements. We have the SBC, the session border controller. It should act like a firewall and it should protect the network from any sort of attacks. So it only should allow calls through if they look like 911 calls and they're formed properly. The two proxies basically pass along information. So on a more complex NG911 system, the first proxy would look at your phone call and it would say, oh, I need to send you over here. In our case for testing, we were testing as a very specific route, in which case we were testing ProxyOne and Proxy2. The types of tests that we did some basic stress testing. Stress testing is supposed to look as if a hacker or an attacker is randomly attacking the network. I just randomly chose an IP. Turns out they're accepting traffic. I'm sending you traffic. Let's see if you can respond to it. And we moved on to smart stress tests, where we know the IP address of the network we're trying to test. We know that it's an NG911 network. We're going to start passing traffic to it that looks like NG911 and see how the network responds to it. And basically, from those smart stress tests, about halfway through, we decided, hey, we should run some tests that look like real-life simulations. Let's put this network under a load that it could see during, say, a disaster or a high call load. So for our basic stress tests, we were basically looking to see that the network is protected from outside attacks. So we were looking primarily at the SBC, a session border controller / firewall. And we were just going to place calls through it and see what it would do with those calls at about a rate of 50 to 75 calls per second. For our smart tests, we were testing all of the different devices on the network and looking at call flow. We were testing each device individually to see how it would respond to a high load, and also the full call through, going through the SBC and through to different proxies. In our real-life simulation tests, we were doing the same. However, the tests were structured a little bit differently to mimic a real-life situation. And in our case, when we were talking, we had a big conference call. We said, hey, let's test this as if there has just been a natural disaster. There's a ton of people calling. How is the network going to respond? The tool that we use to do the testing is SIP-P. It is an open source tool available freely online. You can download this tool. And this tool allows us to set various things within our calls, mainly the rate at which we're calling, the duration of how long the calls, the maximum amount of calls that we are going to make in total. RSA, that feature is very important because we were able to actually direct traffic through a specific device. So when we're starting to test devices individually to see how they would respond, we would use the RSA command to tell SIP-P, hey, send your traffic here first and see how that device responds to that traffic. The -S option is used in our later tests. In the first test, we don't use it. We just make basic SIP calls. However, the -S has to be set as 911. Since we are calling a 911 system, the system has to see, oh, a 911 call is coming through. I know how to route it. And because of the way the system is set, it won't route the calls back to us. We weren't running the SIP-P server, so we would accept the calls. We were allowing it to run through because the way that NG911 is set up, there's a very specific path that the call takes. It doesn't care who you are trying to call. It knows you're trying to call 911, and it knows how to route you. So we were allowing the system to perform that call forwarding. So the results of our testing, once we did our standard stress test, they came back positive. We got exactly what we were expecting. At 50 calls per second, once we ran SIP-P, the SBC was able to accurately here reject all of those calls, since we were just attacking the network. We were just sending garbage traffic. And at 75 calls, it began to falter. It was configured for 50 calls. That's what they told us. We were testing for 50. It passed. Moving on, we decided to start with the smart stress testing, knowing how to configure SIP-P so that the actual traffic passing through the network would go through and would be routed. So we started with testing Proxy 2. We sent some tests through it, and they all came back positive. We got results that we wanted. However, we moved on. This is Proxy 2 right here. As you see, all the traffic that we sent through went through. We moved on and started testing the SBC. And we decided, since it is an SBC, it is a firewall, we're going to route a lot of traffic through it. Once we routed a lot of traffic, we were going to say, hey, this thing's going to fail. It's not going to work. We're looking for that failure. We wanted to really push this thing to a level. However, the failure that we got was way lower than what we were actually expecting. We were expecting a failure at around 50. We got a failure at 5. And we were wondering, oh my God, there's something wrong with the SBC. So right here, we decided to run the next version of these tests on the ProxyOne. We thought, let's finish these tests and let's run on ProxyOne. And after we tested ProxyOne, we found that ProxyOne was actually the device on the network causing this bottleneck. So if you think back to the network diagram, all traffic being routed from the SBC through ProxyOne, ProxyOne was being a bottleneck, only allowing 5 calls at any point in time to be passed through, which, according to what they told us, the configuration was not correct. And that's where these lifelike simulation tests came in. And this was the primary testing that we did on these 2 units. We tested Proxy 1 and Proxy 2 to see how they would respond to a disaster scenario, as I discussed earlier, by sending them a call rate of 5 calls for every 2 seconds and actually sending call traffic through them, so voice data. And we saw that Proxy 1 could not handle the basic call volume. At 5 calls, it was failing, and after some point of time, it would come back online and accept 5 more calls. So as you see here, Proxy 1 only had 8 successful calls out of the 50 that we created. When we moved on to Proxy 2, the same exact test produced completely different results. We were able to get all 50 calls through, and they completed an entire NG911 phone call. So in conclusion, the testing that we did really demonstrates how important it is to do testing on any sort of network. In NG911 network in particular, since it is a lifeline network, people are going to be calling this with 911 calls. This can't fail. This has to work. So it's very important to test the network before it actually goes live. And I know they're doing testing right now before the network does go live to make sure that it is functioning and working as it should be. And also, I believe they're also working on some automated testing, which I've been thinking about, automatically testing your network, where these tests were run through a script. Why not create something that will launch your tests every night? Look at how much call traffic is coming in. If there's not a lot of call traffic, why don't we test all the different devices? Why don't we test every single device on your network, make sure it is working to the specifications that it's configured to? Why don't we test an entire call through from the beginning to the end, make sure that the devices are routing calls properly? And also, why don't we make this automated? Why don't we make it so that every time you update the configuration on your device, run the tests? It should be simple, right? And it can prevent these kinds of issues from showing up. In closing, SIP-P can be downloaded off the internet. If you're more interested in the commands can be found on the website. The slides will be available after this presentation. And I wanted to give special thanks to Professor Davids and Joe Cusimano for help with this project. I don't think I'd be able to do it without them. So thank you very much. Yes. No. So originally when we were setting up our smart stress testing, the original plan was to instead send traffic through the SBC and have someone place a real 911 phone call. We were looking at call quality. That's the original plan for these tests. And we were surprised by this ProxyOne not being able to handle the call load, and that's why we couldn't really do like a call quality test, make sure that we can reach the other end. Can we still hear them if the SBC is being attacked? And what would you do if you are being attacked? Can the SBC handle it properly?
Is there any plan to, assuming that they fix the problem, can you go back and retest?
Can you repeat his question?
Yes, of course. So the question is there any plan to go back and retest the network? For now, I don't know of any plans. I believe we are going back and running the same tests again to confirm at least this issue has been fixed. Moving forward next semester, I believe there is going to be a project to continue testing the network, making sure that it is functioning properly and within standards. Any other questions? No? Going once, going twice? You can't ask questions after this?
Well, I guess, just a comment. First of all, thank you for doing the testing. And there was, I'm going to give you this, because we are being recorded, and I should say this is Barbara Kemp, who works with CSI, the counties of Southern Illinois, and who brought us this project.
Just because I think it is interesting, this project has been delayed. The cutover's been delayed in large part because we needed to finish this kind of testing before the network has live traffic on it. Once we do that, the proactive testing, the volume testing, we don't want to be taking the network down. So I think your ideas for ongoing nightly testing at some quiet time are very good, because there's still a need to keep testing and watching. But the FCC had a major report, if anyone here hasn't seen it, and out in Seattle mostly, there were millions of customers who were without 911 service for a long period of time with a next generation architecture in place, and the equipment from the vendor was located in 2 different places in the country. And they blocked 45,000 calls without anybody realizing it for a long period of time. It was over almost 24 hours. So the FCC is studying it. There's an open notice of proposed rulemaking right now. They want recommendations about certification. And I believe tests like this and studies like this are very important to contributing, and the university has an opportunity to contribute to what kind of testing ought to be done and redone to prove that a network is really ready before it's turned up. Now, there's other best practices that are going to come out of this for operations. And one of them is if you have 2 network elements, because this is a dual network, we only tested one side during this testing, but we should have been able to test that if one side was failing, we would automatically fail over to the other side. And if, say, they were upgrading one side, like they were in the case of that failure, you would only upgrade one at a time, and then your calls would fail over to the other side, and you should get in a maintenance alert or something. So there's just a whole lot of things to learn. We're at the very early stages of deploying next generation 911 in this country, and there have been failures in 3 or 4 states now, at least, that need to be acknowledged, and we need work on this, or SIP is going to look pretty bad, and so is next generation 911. So that's all I wanted to say.
Thank you.
No questions? All right, great. Thank you very much.